can't make it do that day. I'll make it do it on the Wednesday. Okay, so we got a new assignment posted here. It's actually based off of what we did last class, but I'm going to do another example today. So we're going to do another example today that's maybe a little bit closer. But if you remember last time we did the grocery store and we had all the individual grocery items, this is going to be kind of a similar thing. So this is going to be a toll booth. And we're going to pass in a dictionary because it's very common that if you've got make sure I'm streaming, everything's good here, no dropped frames. So, as I mentioned, in languages like C# and Java, those are very heavy object-oriented languages. Like everything that you do is some sort of object-oriented design pattern or something related to it. Python is kind of more of a halfway language. Like we mix some object-oriented language stuff, but then we heavily use these data structures that are data only. I actually like this technique. I prefer it because a lot of times in Java, what you'll find yourself doing is creating classes for stuff that's data only. It can get kind of frustrating. But anyway, so this is very popular. What you'll do is you'll have some sort of class that does what we call the business logic, the actual logic of the program. And then here we have like a data structure. Here we have the individual vehicles. So here we have, this is going to be the license plate number. And then this is going to point to a dictionary. And that dictionary is going to have the type, whether it's a car or truck, and when it expires. I'll explain this very briefly. The idea is that you can represent a date as a number. And so just the idea is that, let's say the current, and I'll add this, because I didn't want to get into date and time parsing, which is kind of complicated. So what I'm doing is I'm letting you cheat and just have a number. Again, like I mentioned, that you can actually use there's nothing here. Let's try this again. I hope I didn't lose the assignment that quickly, because Blackboard will do that. There's something called Unix epoch time that what we can do is it basically tells us how many seconds from 1970, from January 1st, 1970, how many seconds, and then makes it much easier to do like basic mathematics on it because we don't have to worry about like a date object. I'm doing kind of the same thing here, but I'm just using smaller numbers because if you could imagine the number of seconds since 1970, it's a very, very large number. But we're essentially doing the same thing here. Yeah.
I don't know if you noticed it yet, but there's 2 assignment 5s.
Oh. So this needs to be 6. Thank you. The basic idea is we'll assume today's date is 100. But it's this idea that we can represent a date as a number. Why do you think that might be convenient to represent a date as a number? It becomes very, very easy to do comparisons. So if today's date is 100 and I want to know if a license plate is expired, how can I check that?
It's less than 100.
Exactly. So it's a very, very simple comparison. Otherwise, we got to do all kinds of date stuff, and it's not super complicated. I'm just trying not to introduce, a million different things all at once. So we'll just keep life simple. So just pretend today's date is 100. Doesn't matter what that 100 represents. Could be number of days since the beginning of the year, maybe number of months since 1990, something like that, or number of months since 2000. Doesn't really matter. But let's go. So that's out there. That should make sense by the end of the assignment. What I'm thinking about doing is today we'll go through some examples. We'll work on this, and then remember earlier in the semester we did a class where all we did was work on the assignment. I'm thinking that that's what I want to do on Wednesday. So is everyone good with that? So let me send out a quick announcement about that. So that's not an excuse to not show up Wednesday. That's just basically I'm not going to lecture anything new. I just want to make sure everyone's very solid on this because this is not a super complicated assignment, but I think it's obviously for most people in this room, even if you've taken COP2030, even if you've taken other programming classes, this is probably a little bit more complicated than you're used to. So I want to make sure everyone's good on this. So that will be on the 6th. I don't know what I want to call it. Non-lecture day. I don't think that's a good name. In-class assignment day. Close enough. The editor on Blackboard's terrible. I try to bold and then unbold and then unbold the whole thing, whatever. Okay, so everyone gets what's going on here. So that day, it won't be a regular lecture. All we're going to do that whole class is just work on the assignment. But if you're like really good at Python and you understand all this stuff already and you just happen to finish the assignment before then and submit, then I guess you don't have to show up to class. I'm not going to hold it against you. But on Wednesday, if we only have 3 people show up, it's not very helpful. Okay, so let's get started on actual examples. Any questions? Okay. Inheritance is important. I don't know if I want to do another example in it because, to be honest, object-oriented programming, it's not used that often in Python. I mean, it's used, but we tend to use other techniques more often. We use something called duck typing and. Okay, so let's do this. Let's rather than doing another example with inheritance, you already have one example. I'm not going to give you a specific assignment right now. That may be the next assignment, but your current assignment involves dictionaries. So let's do this. Let's go ahead and open up a new REPL. And I want to teach you something called duck typing. Okay. So if you remember from last class, we did our animal example. And if you remember when we had inheritance, it's probably still in here. Let me just bring it up for reference. Let's open it up. Oh, I bet it's still in the history of Notepad++. Okay, at least we got some I don't know if that's any better or worse. The syntax highlighting isn't exactly great here, but anyway. So we'll just use Notepad. To me, that's a little bit more readable. So remember we had the dog and the cat. And it was this basic idea that with inheritance, that any common functionality, any common things, we would take and we would factor it out and put it in a parent class. And because dog and cat are both an animal, we would take that and we would put that into a parent class. For many years, so this idea of inheritance for many years was very well enforced in the industry. It was this basic idea that any sort of common functionality, you wanted inheritance. You wanted these very complex inheritance structures. That way I could get into the whole, okay, well, underneath animal, I could then have mammal. And then mammals are going to have certain qualities that, say, fish doesn't have. And then from there, I could go even further. Within dog, I could get into specific dog breeds. And there's some things, you can get into this whole idea of a taxonomy. And people would often do that. They would create these very complex taxonomies. What would happen is that it would get overly complicated. And we find this in the field of software engineering, that a lot of times people get overly structured, they over-engineer things, they get overly complicated. There's a backlash, and then we get things that are simpler. Does anybody remember XML? So there's a description language called XML. It's still around, it's still very useful. It's incredibly complicated, it's incredibly slow to parse. Then people started coming up with these schema validation systems. They used it with something called, what's the name? It's been so many years since I've worked with it. Hold on. It doesn't really matter. There was a very complicated web service system involving XML, and we have schemas, and we'd have these things called WSDLs. It was very, very complicated just to get a simple project going. So for anybody who's done web programming, we don't see as much XML these days. What do we see instead? So not so much the HTML for passing data around. We see a format called, what's that?
JavaScript?
Close. It's called JSON. It's actually JavaScript object notation. And even then, we're starting, remember we talked about that last class, this idea of JSON? And even then, people are finding that a little bit too complex to use. So we're coming up with even simpler formats. There's one called YAML that's really, really easy to read. Just to show you how much more simple YAML is. Yeah, so this is YAML. We don't have all kinds of curly braces or anything like that. It's just we use indentation, dashes. To me, this is a lot easier to read than, remember we did the Twitter API response? To me, this is, I don't know if I'm crazy, but to me, this is considerably easier to read. So there's this general kind of push toward simplicity. Saying all that, I'll get back to my main point, is that we had all these object-oriented inheritance and all this other stuff, and people treated it as what's known as the taxonomy. They'd create these very, very complicated inheritance structures. And then there was some pushback. I think people just got tired of it. They're like, listen, this is overly complicated. In Java, you can actually only do single inheritance, which made life even more complicated because then they had these things called interfaces, and they had to implement interfaces. And so Python took a different approach. We still do have all that. And last class, you probably noticed me being a little bit dismissive about certain, not dismissive, but I wasn't kind of really focusing on that inheritance model because we don't see that as much. So rather than having this idea of I'm inheriting all kinds of stuff from a parent, in Python we have something called duck typing. And the idea is that if it looks like a duck, and that old saying, if it looks like a duck, walks like a duck, it's probably a duck. And so let's rewrite this animal thing here, but let's write it without inheritance. Okay, so let's say we had a class called dog, and dog does something. And try to keep it somewhat consistent with last time. I guess I really didn't do anything interesting last time. And what we're going to do in these classes is we're going to, just like we did last time, we're going to have speak. Bless you. And let's say, for example, I had just a plain old function, and it was just called say hello. And then I passed in some animal. And then on animal, I called speak. And so I'll make a new instance of dog. Make a new instance of cat. So this is a basic form of duck typing. Let me take a step back. So we've got our dog and our cat. Now, if I were to everyone in here took COP2030, right? Most people in here. When I write a function in C++ or C or Java or any of these other languages, I have the return value, the name of the function, and I can't just write animal, correct? What do I have to write instead? I have to write the data type and then animal. So if I were to write this in C or C++ or Java, I couldn't just say animal. I would have to specify whether I'm referring to a dog or a cat. Now this is where inheritance becomes useful, because instead what I can say is, okay, give me an animal, and because dog and cat are both animals, because they've inherited from it, then that works. Because Python is a scripting language, and because we don't have to really worry about the types that we're passing in here, we could just say, just give me, I'm calling the variable animal, but I've never actually made any class or anything called animal. Does that make sense to everyone? So I've never actually made an animal class. I just happen to say I'm calling the variable name animal. The reason that this is called duck typing is because I don't really care what kind of animal you pass in, whether it's a dog, a cat, a bird, a lizard, a fish, whatever. As long as it has this method called speak, then that's all I care about. That's why they call it duck typing, is because, hey, I don't care if it's actually an animal or not. It could be a robot. We could create a robot class, which is obviously a robot is not an animal, and as long as it has that speak method, that's all I care about. If I go to call that method and it works, hey, I'm fine with that. And that's why they call it duck typing, is, if it looks like a duck, walks like a duck, then that's good enough for me. It may be controversial in other languages, but it's pretty much accepted in the Python community, okay? So it's a kind of a funny term. It might be a little bit confusing, but does everyone get the basic idea? Is that rather than going through this complex inheritance, and other languages have these things called interfaces, that just pass me a variable. If I can call the method on that variable, or on that instance method, if I can call that on there, that's fine. I mean, this could be a module, it could be a class, doesn't matter. If I can call the speak method on animal, that's all I care about. Okay. And maybe I'll do an assignment or something related next class. But let's get back to our grocery store example that we did before. Okay. Okay, so let's open up a new REPL. So no questions on this. Pretty straightforward. Maybe next assignment I'll do something related to that, but I just wanted to introduce the idea of duck typing. And I want to kind of keep this related to your assignment, so let me go back to that. For anybody who hasn't noticed in this class, a lot of times what I do is I do the exact same problem, I just change up the scenario. So in this case, it's going to be toll booth and vehicles, but in our example that we're going to do today in class, it's going to be a grocery store and like items, food items, okay? So let's do this. Let's use inventory. So we create a new dictionary, and the key is going to be the name. So let's say Apple. Oops, colon. I did write colon there, yeah. And then another dictionary. So an Apple is going to point to a dictionary, and then that dictionary is going to contain give me a second here. I want to make sure I'm consistent here because I'm not really consistent right now. Yeah, it'll be close enough. Okay. So this is going to be a slightly different example. We're going to be expanding a little bit. It's not going to be like one of those examples where you can just change the variable names. It's going to be a little bit different, but you should get the idea. And so it's going to have, our apple is going to have a price. Let's say an apple is $1.05. And it's going to have an expiration date. So let's say expires. So I'll just add a few items here. I don't want to use the exact same numbers as the assignment. So I'll let you know, this example is going to be close to your assignment, but there's going to be little things that you have to add here and there to make it a little bit different. You can see that we have no type variable. So what you'll have to do is you'll have to, on your assignment, add an if statement and say if type is equal to car, the price is going to be this. Else if the type is equal to truck, the price is going to be this. But it's not too much of a stretch. It's still very close. Okay. So we've got our inventory. Let's go ahead and make our store class. And so inside of our store, let's go ahead and make a constructor. Remember how the constructor works. The constructor, as soon as we create a new instance of that store, it's created. Oh, and we have to pass in the self variable. So we'll get to that in a minute. What did I call it here? Charge toll. We'll just call this add. And then we'll say name. So it's like almost like we're adding to our cart, to our grocery cart. And I think that's okay for now. I think that's all we really need for now. Okay. Oops. So it's not going to be add name. What is it going to be instead? Self name. Now inside of init, that's usually a good place to put any variables that we're going to be working with. And to me, I might want to know the total. So as I'm adding items in there, I probably want to keep a running total. So that's probably a good variable to have. So let's go ahead and have that. And we'll just start off the total as 0. Let's do this, because we're not really referring to a store anymore. Let's say maybe a better example is cart. So this is our individual shopping cart. I like that name a little bit better. Now we need to get this inventory in here somehow. And let's do this. I don't like having the inventory on the top here. There's a couple of reasons. So let's just highlight this. Usually I like to put all my functions and classes and everything at the top. And so let's put our inventory right here. In practice, we'd actually break this up into multiple files. But, okay. Now, one of the things in the cart has to be aware of the store's inventory. I have to know all the things that I can put into the cart because I have to know, you know, the price and when it expires. So let's do that. Let's say, okay, when I create a new cart, basically we have to tell the cart about all the items that are available at that store. I think last time we just called it INV for inventory. And then we're going to say so we're going to say that our inventory is the inventory that you passed in. So we want to know how much total that we're buying as far as price. And then I want to know what items are available. So pass me the inventory. Now every time I add an item, the first thing I should do is just check to see if the item has expired. So we have to know how to be able to look that up. So this is just traversing dictionaries. And the reason I spent so much time on dictionaries and lists is I want you to get comfortable using them because they're extremely useful. So do self.inventory and then the square brackets because I can look something up. Here I'm going to look up the name of that item. Line number 7, what is that going to return? Is it going to return a list? Is it going to return a dictionary? Is it going to return a string? Is it going to return a variable? After this is evaluated, what's that going to get me? Exactly. So if I pass an apple, it's going to go to self-inventory. It's going to say, okay, give me apple. And Apple's going to say, okay, here you go. Here's your dictionary. So then I take it one step further, and I say, okay, this is going to give me back a dictionary. Within that dictionary, I want to know when that item expires. Now, it's not uncommon when you've got a very long thing like this, like a long string, that you can make a local. I don't want to get into that. Okay. Anyway. And so I want to know if the item is expired. And let's just say just like your assignment, we'll say if the item expired, so what that means is if it's less than some value, I'm going to hard code 100. You wouldn't do this in the real world. In the real world, you'd actually get today's date. I don't want to get that complicated. Let's just say that that's happening. And then we'll raise an exception. We've been using value error. I think this is a good. Okay. So if I try to add something into my cart and it's expired, then I get an exception. So let's go ahead and now actually write some test code down here. So we're going to say C is going to be our new cart. But remember, we have our construction here, or our constructor that's expecting the inventory. So we have to actually pass it that inventory. So right here, we're going to say this inventory that we just defined here, pass that into my constructor. And now within our cart, we have access to the full inventory. We could have made it a global by putting it at the top. I don't like that. That's not a great way to handle it. So, and let's just try to add an item. There's not a whole lot of add logic going on here just yet, but I'm going to do c.add. And let's try apple. We shouldn't get anything. You should just run and that's it. Perfect. Now if I try to add bread, what should happen? Notice the expiration date. It's going to look up bread. It's going to get when it expires. When does it expire? What number? 95. So then it's going to do the comparison. Is 95 less than 100? Yes, that's true. Then we're going to raise this exception. We're going to say, hey, something went wrong. For your assignment, I just said, just ignore the exception. That's fine. So let's try to change this from apple to bread. Perfect. We get a value error that the item has expired. If you want to go the next step in your assignment and actually do a try catch block, you can do that. Or try accept, I should say. But I'm not going to make you do it for the assignment. There's a million things I can throw at you. Sometimes I just have to say, okay, that's enough. Okay, so that works. So if I try to add an expired item, we get an exception. Perfect. So let's go back to apple. Now I have to actually go into my logic here and say, okay, remember, with an exception, when it raises that exception, it's not going to go any further. So if I get to line number 10, I know that the item is not expired. Does that make sense? So basically, when you raise an exception, unless you handle it, which we're not handling it, it's not going to execute any of the code. So at this point, at line number 10, we are guaranteed that the item hasn't expired. So now we can do some basic things here, but let's just keep it simple. Let's get the price of the item. So we'll say self.inventory. Then before, so that's going to return a dictionary. Before we wanted to get when it expired, but now I want to get the price of that item. Now if I want to add it to the total, what would I do? I can't just say self.total equals this thing. What do I have to do instead? How do I increment it? What little special character did we learn? So let me do this. We'll do self.total something. What do I have to put that something there? If I want to increment the total every time I add an item, what do I have to put there? Plus equals. Perfect. And what that's going to do is that's going to increment. The total starts at 0, and then as I add items, I'm going to increment the price. I'm sorry, I'm going to increment the total based on the price. So if I add 2 apples, and I printed c.total, which should that print? So $1.05 plus $1.05, $2.10, or it's not gonna format it, so it's just gonna write 2.1. Just make sure we get that. Perfect. Now, you don't have to do this on your assignment, but one thing that we did talk about last time is that maybe you want to print the current state of your program. Let's skip that. I don't want to make it more complicated. You're welcome to do that. If you remember last time we talked about the REPR, the representation string. You can add that to your assignment if you remember what that is. But this is kind of the starting point. Okay. Let me actually. I think if I save, actually no, I'll just post the source code like I normally do. Okay, so let's take a step back. So we created a class called cart. That's going to be our shopping cart, and we created a constructor. Remember how constructors work is that when we make a concrete instance of that cart, which we did here, line number 18. Here we actually made a concrete instance of that cart. This function is called. These underscores basically mean that it's just like it's a special function. We called them dunders for double underscores. And it's a method. And we took that opportunity to set up a new variable called total. And that total is going to be 0. But we also said, okay, well, if they have an inventory, go ahead and pass it to us so we know what's available. And that's also what we did. As an argument, we passed in the inventory. We said, okay, our inventory is that inventory that they just gave us. Perfect. So we've got our total and our inventory. Now if I want to add an item, I go back to the inventory dictionary and I look up that item. And I want to know if it expired. So the basic logic is that we've just got some numeric system of dates that the current date is 100. I just hard-coded it. It's not a great way to do it, but I want to keep the assignment simple. And if the number is less than 100, that means that date is in the past. So if that current item has a date in the past, then it's going to throw an exception. It's going to raise an error. In this case, I chose value error. May not be the best error, but it's fine for here. And if we get to line 10, great, because that means that we haven't, that exception wasn't raised. So if we get to line number 10, perfect. We can go ahead and actually add that item to the cart. And then starting at line number 18, we wrote some test code. We tested a couple of apples, printed the total. And then remember, if we wanted to add, let's add a couple apples and then add milk. Make sure that's all good. Perfect. And then it's not until we try to add, bread. Well, our bread has expired and we get a value error. What you'll realize in real world code, there's error checking everywhere. And this system of exceptions turns out to be very useful. Because, say for example, like I accidentally was going to type the word break because that's used in Python. What's going to happen here if I try to add a break, not bread, let's say just a simple misspelling, what's going to happen? It's going to raise an exception, what's called a key error. Yep, exactly, key error. So then you'd probably want to handle that. So you'd probably have something that catches a key error that says, oh, I can't add this item because it's not available. And then maybe another thing to check that checks for expired items. There's just always all kinds of error checking that you can do. Real world programs, this little 25-line program in the real world would realistically be more like 100 lines once you got through all the error checking. and all the, all that sort of stuff. So I'm trying to give you a little bit of a taste of exception handling, but in the real world, you're gonna see that most of your program tends to be a lot of this error checking and very little actual logic. I remember I saw a study one time. Java is very verbose as a language to begin with, but I remember somebody did a scan of a bunch of open source projects, and they found it was some extremely high number. It was like over 85%, 90%, something in that range of code was actually just error checking or some sort of other logical code. Checking to see if that, think about all the things that could happen when somebody goes to check out. Do they have enough money? Did the network connection drop off? Was there a database issue? There's just a million different things that can happen, and so you have to take into account a lot of these things when you're writing code. Okay, but this is about as complicated as I want to get. So any questions about this example? So now knowing this, let's see how that applies to your assignment. So use the code from today that we just did as a starting point. So now instead of a cart, we're going to have a toll booth. And rather than an inventory, we're going to have vehicles. We're only going to have 3 vehicles, but you could pretend that this would be the entire DMV database or something like that. And let's pretend that ours is a very sophisticated system. It goes through and it has license plate recognition. So you go through and it automatically gives us the license plate. So that's what these are right here, license plate numbers. So for short, just LPN. And we have the same expiration logic because, license plates expire, car registrations expire. So that logic is largely going to be the same. But now we have something a little bit different here. Because I'm not hard coding the price of the vehicle. I'm just saying its type. Does that make sense? The difference? Because, so I'll come back to that in a second. And then now we're going to have charge toll, where rather than passing in the grocery item name, we're going to pass in the license plate number. Now what's going to be different about this? We can't directly look up the price anymore. So what do we have to do instead? We have to put an if statement in there that says if type is car. So we're going to look up that vehicle, get its type, and check to see if it's a car. And if it's a car, increment it by, so we're going to charge the toll $1. And then if the type is truck, we're going to increment it $1.50. Okay, so minor change, but notice that we can't just directly look up the price anymore. It's based on the type of the vehicle rather than the actual individual item. Okay? And just like before, assume that today's date is 100 just for testing purposes.
I like how on the highway they have signs that say, if there are special laws, vehicles with certain numbers of axles, right?
Exactly, yeah. And yeah, so I didn't want to get overly complicated and get into axles. That's why I just said cars and trucks. So any questions about that? Okay, so you have about a half an hour. I think some of you actually might be able to get through this completely. If not, like I said before, we have Wednesday, but if there's no other questions regarding any dates or anything, I'm just going to go ahead and stop streaming. Is that okay? Good.